Hello, MATLAB and Python users. Today we'll be looking at different deep learning frameworks comparing MATLAB to TensorFlow and PyTorch. For this, I'll be using a very basic example, which is essentially the quick start tutorial for both TensorFlow and PyTorch, called the fashion MList. It's a dataset containing 10 classes of different clothes, shoes, handbags, and t-shirts, and so on. So let's start with looking at MATLAB. And for this, I'll be using MATLAB inside of Google Colab, and you can find another video here on the top right inside of my channel on how to get it working. So here I've installed MATLAB through the terminal. You can check that you have indeed a Tesla T4 GPU enabled and all of those products were installed. Let me check here. I have my NVIDIA GPU. I've installed everything properly, like mentioned in my previous video, and it's opening MATLAB in another tab inside of the same space of my Google Colab. I've also mounted a drive, a MATLAB drive, so that I can access my content inside of Google Drive. Here it's going to be stored inside of Python and Fashion. Okay, so this is the content. Actually, let me delete the PyTorch implementation, and here I'm going to be deleting the data. I'm going to read or download all of it. For this part, I'll be mostly using the MATLAB engine to call MATLAB from Python. So let me first enable the MATLAB engine, start the engine, gentlemen, share your engines. All right, this way I can go back over here and establish a connection with the MATLAB engine to connect to MATLAB from Python in the same session. I'm going to also start TensorFlow in order to get the dataset. And this is simply enabled as one of the datasets that are shipping with TensorFlow. Let me change the current working directory on the Python side to be the same as the MATLAB one and initiate the connection with MATLAB. So here you can essentially set inside of the workspace all of those data sets that have been downloaded on the Python side. And now if you look at who's, which is going to be telling you what's inside of your MATLAB workspace, you'll see all of those variables that have been rightfully populated, and you can find them over here as well. So the first thing you'll do is we're going to reorder all of this and change the name of the variable that we'll be using, xtrain, ytrain, xtest, and ytest. And here there's just some reordering. You can check the reordering algorithm that I have inside of here. It's just switching around the dimensions so that it fits with the way MATLAB is ingesting these types of data. And now we're going to push it back, and if you go back here, you can see that all of those also have been set correctly as a categorical, the labels as categorical, because that's essentially the way MATLAB likes to consume data, labeling data for classification. So now we've done all of this, let me start the Deep Network Designer, and that's going to be the first interesting part of the demo, showing how you can design a network interactively inside of MATLAB. So this is going to be opening here first this interface, and you'll also have a welcome page that enables you to choose from different options. So here the first option would be to create a blank network, open one from the workspace, or import from TensorFlow or from PyTorch. We won't be covering this in this video, but stay tuned, I'll cover this in future videos. So those are the options. As you can see, there are here a need for additional support package, and I can show you in some of the video how you can retrieve this support package. You have this covered in my previous video about MATLAB in Google Colab. And here you also have some existing pre-trained network. I'm going to create one from scratch. So here, in order to create this neural network, I'm going to take some inspiration from the implementation in the TensorFlow tutorial on their website. So here they define a very simple neural network that is composed of first flattening layer, a dense layer, which is essentially a fully connected layer. There's an activation function, which here is passed as a parameter of the fully connected layer, and a last one that will connect everything down to 10 classes only. And then all of this is going to be consumed by the optimizer with a loss function. So I'll get into this step by step. So let me go back inside of MATLAB, and here you can pick and choose the different elements that you want in order to create your network. The first part will be to take in an image that will be 28 by 28 with only one color. It's going to be between black and white, so no 3 channels of red, green, blue. Now what we're going to do is look at a flattening layer, which is going to take this 28 by 28 into one single string, one sequence of 784. If I'm not mistaken, that's 28 by 28. So this is going to do the calculation automatically. And now let's put the fully connected layer. This one, we're going to use a dimension of 128. So we're going to go from 700 something to 128. And we're going to be correcting this by an activation function, the ReLU layer. The what does it stand for? I'm blanking. Rectified linear unit. Okay, got it. So let me connect it. Perfect. And finally, the last layer with only 10 dimensions. Perfect. And let's connect to an output. So in MATLAB, you'll need to explicitly connect the last layer to a softmax layer, which will do essentially the distribution of probabilities for each of the 10 classes that we want to predict. Okay, perfect. So let's move to our range so it looks good. Damn it. Okay, perfect. You can also type space. Once you've done this, you can analyze the network. So we're going to be training those 100,000 and something neurons. And now that it's all good, let me output the network inside of my workspace as net_1. Perfect. So now I can minimize this window, and here I have a neural network, net1. Let's go back in here. It's telling me that I'm not using the GPU just now, but wait a minute, it's gonna happen. So I'm gonna get this variable on the Python side in order to pass it to my training network function. And you'll see in a moment what this function does. Let me go back on the MATLAB side. So this is opening a view into the training process, which is going to take about 2 minutes, I think, on this GPU with 10 epochs. So we're just going to take all of the 60,000 data from the training set, and we're going to be passing it into the network 10 times in order to essentially train the weight of the neuron. Okay, it took slightly longer than I anticipated, almost 3 minutes as it's ending right now. But as you can see, it's converging. Actually, way earlier than 10 epochs, so I didn't really need 10 epochs for this. But that's the way it is with deep learning. You got to try an experiment and vary the parameters. Okay, so now let me close this interface. Our neural network has been trained. If I look at here the function that I used for that, it has been using the Adam solver in order to perform this optimization, and it's using the loss function called cross entropy. We'll see that also in the next two frameworks. Okay, so now let's go back on the Python side and export the network on TensorFlow. So this here is gonna error because this function export neural network is not defined. So if I run it, it's going to tell me, okay, I don't have this function defined. It means that I need to install the support package on the MATLAB side, which I'm going to do just now. Let me go to add-ons and search for TensorFlow. Okay, this is the first one. Perfect. Now I can go back and export the function to TensorFlow. So it is going to be storing here a package, which I can see on this end over here. Here, this Python package with an init function and all of the weights and the model are going to be essentially usable directly on the Python side. Before I do that, let me share with you here the whole process that you can view inside of my Git repo, with also a way to download separately all of the data sets directly from MATLAB. And all of the steps here that I've shared with you, you can do interactively, or you can also do programmatically to define all of the layers, the training options. I can here also look at the accuracy. So it's about 88%. And you can also look at a confusion matrix that will list essentially what is predicted correctly on the diagonal and what isn't on all of those red squares. So this is giving you a sense as to how the model performs. And it's pretty good. So now that we've exported it into TensorFlow, you can also import it on the Google Colab front. So let me import this model, load it, and look at a summary. And it looks pretty much the same as what we've done on the MATLAB side, which is each of the equivalent for all the layers on the TensorFlow front. And you can use it just simply by doing model.predict, passing the test images and getting back a prediction. So this is it for MATLAB. Now let's switch to TensorFlow. So on the TensorFlow side, we're going to be importing TensorFlow as TF. We'll be implementing the model as such, just like in the tutorial. As you can see here, you start by an input function, you flatten, you introduce a fully connected layer, which is called dense. In TensorFlow, you're not adding a layer for ReLU, you're actually passing it as an activation function, as an argument to the fully connected layer. And then finally, you end up with a dense layer of dimension 10, and that's about it. Now let's look at the summary of this model. It looks a little more compact. You don't have all of the same layers that are represented on the MATLAB side, but that's essentially equivalent. You can see the same number of parameters, 100 and something, 101,000 parameters. What you need to do first is to compile the model, and for this we'll be using the Adam optimizer as well. We'll be setting up the sparse categorical cross entropy, which is the same, the equivalent of what we have on the MATLAB side for cross entropy. And let's just calculate the accuracy as a metric and fit the model on the training set, which just let it run for 10 epochs. Okay, the training ran successfully for 10 epochs. And now let's just simply evaluate on the test set to see what the accuracy is. It's 84%, which is slightly lower than what we got in MATLAB, but it's very similar, so really nothing to worry about. And let's do a prediction. Here you can see what has been predicted on the test images. We can turn this with the argmax function into a set of predicted labels, because here you have distribution of probabilities for each of the 10 classes for all of the datasets, the test datasets, and compare it with the predicted label with the test labels. And here you come up with the same, which is 84%. So this is essentially how accuracy is being computed manually. And you can also use a confusion matrix to just compare what may have gone wrong in some of those categories. So that's it for TensorFlow. Now let's do PyTorch. Okay, so PyTorch is interesting. It's kind of a different paradigm, and you'll see here from the tutorial that first of all, you might want to be using their datasets directly. That's going to be easier to get the data inside of PyTorch, because they use this notion of data loaders. And I'm not going to get into that in this video, but something for you to take a look at, as it's quite different from the way MATLAB and TensorFlow are proceeding. And then we look at how to create the model, which is also quite different because they are using a more Pythonic approach based on object-oriented class definition. So let's just go through the example with importing Torch, the data loader, the dataset, and also the transformation to tensors, which is quite a lot, but we'll take it step by step. Okay, so let's upload the dataset directly from their sample datasets. We're going to be using a batch size of 64, which was the same as what we've used before, making sure that the shapes are correctly ordered. Yep, all of the different inputs, using the GPU that we have access to, and defining the model. So here you start by this init function, which is going to be initializing the neural network by inheriting this class nn.module, which is the way you create any neural network in PyTorch. You just subclass this and you use this super function in order to inherit all of the methods from this class. And then you start defining the flattened layer, the linear ReLU stack, which is going to be an n.sequential, a sequential list of linear 28 by 28 to 128, then a ReLU function, and then finally mapping an input from 128 to 10. So it's kind of like a slightly different representation, but it's similarly the same. And here also implementing a forward function, which is going to be what is going to be used in order to do the prediction. Okay, so now let's define a loss function, which is going to be the cross entropy loss, and an optimizer, the Adam optimizer, with a learning rate of 1 to the -3. Let's define a training function. It's quite verbose, as you can see, and a testing function. So you can pause the video now and take a look at this. I'm not going to go into detail, but I'll just want you to take a look at the way it behaves so that you can see what PyTorch does. Now let's iterate. As you can see, it's a little more Pythonic, and it's also they argue it's better for debugging. Let's give it 10 epochs again. Okay, 10 epochs have passed, and my neural network is ready. So now I can save it, serializing it to disk in this format. I'm actually going to need to use another format, the saved model format, in order to export it to MATLAB, but then again would be covered in another video. For now, I'm going to reload it directly in order to make a prediction. So here are all of the classes. I'm going to be turning the model into eval mode, and now I'm going to be doing a prediction. and looking at here the predicted versus the actual, comparing it with the test set. Now let's do that for all of the prediction, so iterating over the entire test set, and as you can see, the accuracy is quite similar to what we've gotten in MATLAB. And you can once again take a look at the confusion matrix to compare where this might have guessed wrong. And that's it for PyTorch. So maybe a few elements about PyTorch. Here my friend ChatGPT gave me a few elements about explaining how class definition in inheritance work. I mentioned to you that you're going to need to subclass the torch.nn.module. It's the base class for all neural network in PyTorch, and it provides you all of the facilities, the utilities you need in order to run a neural network. You're going to be using this constructor init to essentially set up all of the parameters and everything. And finally, you're defining the layers, and we've covered that quite similar to what we've done in TensorFlow at this level. Let me take a moment to compare the architecture of the model in the tutorial, because if you look at the tutorial on the TensorFlow website versus the PyTorch website, you'll see that here it has a slightly different and deeper architecture on the PyTorch website, and you can quite interestingly compare here how those different architecture behaves. It's slight differences, and here you essentially have a deeper neural network on the PyTorch side, which adds this hidden layer that is essentially the same dimension, so no real additional complexity here, but it ends up being much larger overall in terms of the number of parameters because of this additional hidden layer. So this was it for MATLAB versus TensorFlow versus PyTorch, and I hope you learned a bunch, and if you liked it, feel free to share it with your colleagues and follow my channel. Thank you so much, and bye-bye.